Hey everyone, in today's video we're going to be solving the problem candy on Leetcode. So the question says there are n children standing in a line. Each children is assigned a rating value given in the integer array ratings, and you are giving candies to these children subjected to the following requirements. Each child must have at least one candy, and children with a higher rating get more candies than their neighbors. Return the minimum number of candies you need to have to distribute the candies to the children. Okay. So what the question is saying is that let's say you have n number of children. Okay. So here the ratings array signifies that there are, let's say, three children standing over there. Okay. And all these children have a rating value with them. And these rating value, let's say the first child has a rating of one, the second child has a rating of zero, and the third child has a rating of two. Now, what the question says is that each child, over here, each child has one candy associated with them. Okay, so there's one candy associated with each child. Let's write it properly. Okay, so there's one candy associated with each child. Okay, and children with a higher rating get more candies than their neighbors. Okay, so what do you need to know over here is that let's say one over here has a rating higher than zero. Okay, so here one will have a candy more than zero. Now same goes for zero, but zero has no one. If zero is not greater than any of its neighbors, so it'll have only one candy, and two is greater than its neighbor zero. So therefore, it'll have one more candy than zero. So it'll have two candies. So in that way, you need to find the minimum number of candies you need to have to distribute to the so that you need to have to distribute the candies to the children. So over here, if you probably will only need four plus one, five candies to properly distribute the candies among the children in this case. Okay, and let's understand the question in this scenario. When we look at this scenario, what you see is that over here 12 has is greater than its neighbor, right? So firstly, let's just assign one candy to all of them. Okay, so one candy is assigned to each of the child. Okay, now let's see over here 12. Now 12 is greater than its neighbor 4, so it'll have one more candy than its neighbor. Okay, so it'll have two candies. Now when we go to 4, it is lesser than its neighbor 12, but it is greater than its neighbor 3, right? So it'll again have one more candy than its neighbor 3, so it'll have two candies. Now, 3. 3 is lesser than both of its neighbors, so it'll have only one candy. 11 is greater than its neighbor 3, but lesser than 34. But it is greater than 3, so it'll have one more candy than its neighbor 3, so it'll have two candies. Now, 34 is greater than its neighbor 11, so it'll have one more candy than its neighbor 11, so it'll have 2 plus 1, 3 candies. Okay, now 34 is greater than its neighbor 1 over here. Okay, so it'll have one candy greater than 1, and 1 is not greater than either of its neighbors, and 67 is greater than 1, so it'll have one more candy than 67 will have one more candy than 1. So this is how many candies would have been needed to be distributed to give to these children with these rating systems. Okay, so the total would have been 2 plus 2, 4, 5, 6, 7, 7 plus 3, 10, 12, 13, 15. So 15 candies would have been the total that would have been needed to distribute among these children. Okay, so now the very first thing that might come to your mind when looking at a problem like this is that you might need to solve it using a sorting algorithm or something like that. Okay, but no, because over here, if you sort the array right now, then the neighbors, let's say 4 is over here, it has a neighbor of 3 and 12. This pattern might break because 4 needs to be in between 12 and 3 so that we understand whether we need to increase a candy for 4 or whether it doesn't need to be increased, because basically we need to know whether it is greater than its neighbors or not, right? If we sort it, the balance would be broken of the array and we wouldn't know which one is greater than what. Okay, so you can't solve the problem in that manner. So how do you solve this problem? So one way to solve this problem is to take the array over here. Let's take this question, and what we'll do is we'll firstly loop through the array from left to right, then we loop it in right to left. Okay, when what I mean by that is, firstly, let's see, when we loop the array from left to right. Okay, we have 3, 1, 2, 3, 4, 5, 6, 7, 8. We have 8 elements over here, right? And we'll assign one candy to all these children. Okay, now after assigning one candy to all these children, what are we going to do? What we'll do is we're going to loop from left to right now. We'll loop from the very first element of the array to the very last element, and we'll check if this element is greater than its previous element or not. Okay, only from its previous left element, not from its right element. We just check whether it's greater than its leftmost element or not. its direct left element or not. Okay, so when we start from 4 over here, okay, we see that 4 is not greater than 12. So we won't increase the number of candies for 4, and the number of candies for 12 will initially be only 1, okay, because it has no left neighbors over here. Now, when we go to 3, we see that 3 is not greater than its neighbor 4, so we won't increase the number of candies. Now, when we go to 11, we see that 11 is greater than its neighbor 3. So, what we'll do over here is we'll increase the number of candies for 11 to 2, which is basically just add the number of candies 3 has and just increment it by 1. Okay. Now, when we go to 34, we see that 34 is greater than 11. So, over here, we'll make this 3. We'll basically just increment the number of candies 11 has with 1, which is 3 now. Now, when we go to 34, we see that it is not greater than 34. We'll just leave it as that. Then we go to 1 over here. When we go to 1, we see that 1 is again not greater than 34. So we'll leave it as that. And when we go to 67, we see that 67 is greater than 1. So we'll just increase the number of candies 67 has by 67 has by 1. Basically, this 1 over here has 1 candy. So we'll just increment 67's number of candies by 1 plus 1, which is 2. Okay. So after we made the left array, we'll make a right array as well. Now, what you can do over here is you can just not sort, you can just reverse the array over here because it'll just become easier for you. So what you can do over here is do the same procedure completely what you did by making this a left array, or you can just loop through the array in a from right to left fashion. But I prefer this. It'll just it just reduce the number of loops I have, basic number of lines of code I have, because I can just write this in one line in Python. So that's why I'll just do this. So if after I reverse this, okay, I'll do the same thing again, right? Let's just 1, 2, 3, 4, 5, 6, 7, 8, right? So we have 8 elements. Now this time we're going to do the same thing. We're going to check if 1 is greater than 67 or not. Okay, we'll just check whether this element is again greater than its left element or not. But we're naming this as right to left because basically what we're doing is in a right to left fashion. We're just checking whether this 1 is greater than 67 or not. And we just reversed it over here. That's why we're just writing right to left over here. And this array's name as right to left over here. Okay, but the loop is going to be the same. You can just loop the whole thing in the same array and just give this a ratings array, and this is a ratings 1 array, okay, or ratings 2 array or something like that. So you can just run the whole code in one loop. Okay, now just check with this one with 67 whether it's greater or not. So this one is not greater than 67. We'll just continue. Now 34 is greater than 1, so we'll just increment the number of candies 34 as by 1, which is 2 now. Now this 34 is not greater than the previous 34. Okay, so we'll just leave it like that. Now again, 11 is not greater than 34. We'll just leave it like that. 3 is not greater than 11. We'll leave it like that. 4 is greater than 3. So we'll just increment this by 1. And sorry, we'll increment this by 1, which is 2. And 12 is greater than 4. So we'll make this a 3. Okay. I hope you understand why we did a 2 and 3 over here. Just because 3 has 1 candy. So 4 will need to have 1 more candy than 3. So we'll have 2 candies over here. And 12 will need to have 1 more candy than 4. So we'll have 3 candies over here. Okay. Now, 1, 2, 3, 4, 5, 6, 7. Why is it 1 less? 3, 6, 7, 7, right? So I think there'll be 1 more 1 over here. Okay, so this is what it is. Now, what we do is after we make a left array and a right array, what we do is we take a total over here, and the total will just add the values of max of this one and this, the max of L2R and R2L for each index. Okay, and why we doing the max of it over here? The reason for doing the max of it is because we need to find which is the maximum, maximum amount of candies that particular element will have from its either neighbors, right, left and right. And the maximum value from left and right will basically signify the maximum amount of candy that person will need to have at that point, right? So that's why we're going to do a max of left and right. Now when we do a max of left and right, we're just going to see from the very first index over here. What we'll do also over here is we'll have to reverse this. Because we reverse this array over here, we'll need to reverse it again so that we get this order for this L2R R2L array. Okay, so what we do is 3, 2, 1, 2, 1. So we'll just write it over here, 3, 2, 1, 2, 1. Okay, so this is what the array would look like now. And later on, we'll just find the maximum between these two indexes and we'll just add them to total. So over here, the maximum between this one and this one is basically just 3. So we'll just make it a 3 here. Then between 2 and 1, it's 2. Then between 2 and 1 again, it's 2. Okay, so it's here 1. From third element, it's 1. From the fourth element is 2. From the fifth element is 3. From its six is 2. From 7, 1. 7, 8, 2. Now when we add all of these, we'll get 2 plus 1, 3 plus 2, 5 plus 3, 8, 10, 11, 12, 13, 14, 15, 16. Wait, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so maybe I made the math wrong in the start. But yeah, you'll get 16 over here as the output. And 16 will probably be the right answer. Okay, when you add these all up together, you'll get a total of 16, and you need to return the maximum number of candies that person will have to be as 16 over here. Okay, so now let's just copy this one over here. I hope you understood what the procedure for solving this algorithm is, guys. And the reason why we can't use any sorting algorithm over here is just because we don't want to hamper the structure of the array. So that if we do hamper it, we probably won't get the right result in the end. Okay, that's why we won't hamper it, and we'll follow this procedure to solve this problem. Okay, now let's just remove this. And this is what the code is for this question, guys. Firstly, we'll make an array L to R and we'll assign 1 to all the values present in that array, which is basically going to be the length of ratings. So we have, let's say, 6 elements which we previously had. So there'll be 6 elements with 1 values present over there. Same for R, we'll have an array with 6 ones present in it. Then we'll just reverse that array rate and make it a ratings 2 so that we can do a right to left loop through it over here. Then we'll just make a total counter over here. Then we'll just loop through the array from 1 to length of ratings, and we'll just check if the current rating is greater than the previous rating, just previous element of it, or not. If it is greater, we'll just increment the value in the ratings by +1. And it's the same for R2L. We'll just check if the first element is greater than its very previous left element. If it is greater, then we'll just increment it by 1. And later on, after the result what we get for R2L, we'll just reverse it again so that we get a proper structure for the answer, like I showed you right now. And then we just find the maximum between L2R of I and R2L of I, and we'll just add it to the total value and we'll return the total. Okay, so let's just run the code. Yeah, it's running, guys. And let's just add one more test case over here and see. And this test case which I put over here, let's run it with this also. And yeah, it's coming correct. It's 16. Yes, 16 is the output over here. And let's submit the code. Yep, it's running. So yeah, guys, that's all for today's video. If you like the video, do like, share, and subscribe. Do leave a comment below whether you like the video or not. Let me know below what I can do better in terms of teaching the code over here for these algorithms. Also do check out the podcast and also do comment below what kind of problems you want to see next in the channel. And until next time, guys, thanks for watching.